Okay, we are going to now learn how to convert from one unit in the metric system to another unit. And a lot of you, I know, are used to moving the decimal place. But what we are going to do is learn a new technique called factor label or dimensional analysis. And why we are going to learn this is because we will be using it extensively throughout the year, and you will be using it extensively throughout your scientific career also. It's a common way to solve problems. So let's get started. When we use factor label or dimensional analysis, the idea is that you're going to multiply by 1. And you can multiply any number by 1 and not change the value of that number. We are going to multiply by 1 in such a way that we end up with the unit that we want. And so how we do this, if you look down here at this part right here, if we're going to convert 7 centimeters to kilometers, then we are going to multiply by 1 so that we get this 7 centimeters in meters, and then from meters we're going to go to kilometers. Now 1 meter and 100 kilometers are the same thing, so I'm multiplying by 1 here, and 1 kilometer and 1,000 meters are the same thing. So I'm multiplying by 1 here, but I'm doing it in such a way that I end up with kilometers. So that's the premise of factor label, dimensional analysis. What you'll need to know for doing this is your equivalencies, your conversion factors. That is what we'll be multiplying by. And 1 kilometer is 1,000 meters, 10 decimeters is a meter, 100 centimeters is a meter. So I've listed the ones here that you need to know. Notice this is a micrometer. That's not quite the symbol for micrometer, but it's the closest I could get to it. And this is a nanometer. Now remember, all of these can be inverted. In other words, I could have written 1,000 meters over 1 kilometer or 1 meter over 10 decimeter because they're the same, they're equivalent to each other. They're the same thing. And we are going to choose when to invert them and when we're not going to invert them based on what our problem is. So let's look at a couple examples. The first example is how many meters are there in 12.34 micrometers? The first step is to write down what you're given, and you're given 12.34 micrometers. Now we know we want to get to meters, so we're going to multiply it by 1 in such a way that our micrometers cancel out. And so you see what I did here is I said, well, I know there's 10 to the 6 micrometers, 1,000,000 micrometers in 1 meter. So I'm going to multiply it by that conversion factor, but I'm going to put the micrometer on the bottom so that it cancels out. And you see that it does. Then it's just a matter of going 12.34 times 1 divided by 10 to the 6th. And we get 1.234 times 10 to the negative 5th. The last thing we want to do is check to make sure our units come out correctly. If they come out correctly, then we did it. Then as long as we use the correct numbers in the equivalency, we did the problem correctly. Okay, example 2, how many millimeters are there in 7,734 nanometers? Now this is as a little bit trickier because you say, well, I don't know how many millimeters there are in a nanometer. You didn't say we had to know that. And you don't. All you need to know is how many millimeters are in a meter and how many nanometers in a meter. And you should know that. And so this is what we call a two-step problem. And if you look closely here, what I've done is I've started with what I'm given, 7,734 nanometers. I want to get nanometers gone. So I put that on the bottom. And I know that there's 10 to the 9th nanometers in 1 meter. So that's why I put the nanometer on the bottom. Now I want to get meters. I want to get rid of meters. So this part here, I have meters on the bottom. And I want to convert it to millimeters. That's what I'm asked for. So 1,000 millimeters is 1 meter. So I look at what's been canceled out. I have my nanometers canceled. My meters are canceled. So I go 7,734 times 1 times 1,000. And then on the bottom, divide it by 10 to the 9th. And you end up with 0.07734 nanometers. And in scientific notation, 7.734 times 10 to the negative 2nd millimeters. Right, example 3. I'm not allowed to drink more than 200 milliliters of 5-hour energy. I've never had 5-hour energy, and I really don't think anybody should be drinking 5-hour energy. But if this was the problem, how many cubic centimeters is this, and how many liters is this? So this is actually 2 problems. So first we have to say, what do they mean by cubic centimeters? Well, the symbol for cubic centimeters is centimeters to cubed power. Okay, now again, I start with 200 milliliters, and I'm going to say, let's change it to liters first, because that's easy. I know there's in 1 liter, there's 1,000 milliliters. Milliliters, sorry. Notice I put milliliters on the bottom, because I want that to cancel. Liters is on top, so 200 times 1 divided by 1,000 is 0.2 liters. Now, let's go to cubic centimeters. And the one fact you had to remember here was that 1 centimeter cubed is equal to 1 milliliter. So 200 milliliters divided by 1 milliliter time, and then times 1 centimeter cubed is 200 centimeter cubed. This second problem, once you recognize 1 centimeter cubed is 1 milliliter, you probably right away came up with 200 centimeters cubed. Now example 4, and this one is going to be a challenging problem for you. If I drive 65 miles per hour, how many kilometers per second is this? The first thing, which I have already mentioned in the previous tutorial, was you need to know how many miles are in a kilometer. And I'm just reminding you, there's 0.6 kilometers in 1 mile. Now, we're going to set this up because we actually have to do 2 types of conversions. We have to change miles to kilometers, and we have to change hours to seconds. What am I given? So you go 65 miles per hour times. And I chose to, let's change our miles to kilometers right away. So I'm going to multiply by 0.6 kilometers over 1 mile. You see miles and miles will cancel out. I still have this. My answer here would be kilometers per hour. And I want kilometers per second. So I've got to get rid of my hours. But remember, hour is on the bottom. So if we want to cancel out hour, we have to put it on the top. And I say, okay, well, I know in 1 hour there's 60 minutes. Okay, so far so good. My hours are going to cancel out, but now I have minutes on the bottom, not seconds. No problem. I can then convert the minutes to seconds, making sure I put seconds on the bottom, because minutes is on the bottom here. I want 1 minute on the top here. I go 65 times 0.6. Times 1 divided by 60 times 60, we get 0.01 kilometers per second. Why should I use factor label instead of just moving my decimal? There's lots of good reasons, but I know students like to move their decimals. One is it will prevent mistakes. Okay, a lot of times students, when they move their decimal, they move it in the wrong way. The other thing is it makes hard problems easier to follow, like in the last problem when we had to change both kilometers and the hours. If you just take it step by step and change your units, look at your units, those become pretty easy problems. The other thing, it allows you to check. If your units don't come out right, you've done something wrong. YouTube, there's over 43,000 tutorials on factor label or dimensional analysis. Now, why would there be that many if it wasn't a really good system to use, huh? So, and then here's a video that I thought was pretty good. If you're still having trouble with this, you might want to watch this. It might really help you quite a bit. He doesn't go into a harder problem like example 4, but he does the basics really well.